analyze objects that are moving not with constant velocity like we already studied. We are going to analyze objects that his velocity is changing. So they are objects that are moving with velocity that is changing all the time. But we are going only to study the case when the velocity is changing at a constant rate. It says that the acceleration is constant. When the velocity is changing at a constant rate, the acceleration is constant. So what we have seen for the moment, we have seen motion with constant velocity. What are the graphs of the motion with constant velocity? When the velocity is constant, the graph of the velocity of the position respect to the time is a rectilinear line. The slope of this graph is the velocity. Then the velocity is constant. So the velocity, the graph of the velocity should be like this, should be constant for all time t. For all time t should be the same value. So we say v equal v0. And of course, because there is no change in the velocity, the acceleration should be 0. A should be 0. So the equation that we have used for motion with constant velocity were x equal x0 plus v0 multiplied by t. And this equation is written when the conditions are satisfied that the velocity v is constant, is v0, is always v0. And of course, if the velocity is constant, the acceleration is 0. So this is a motion with also constant acceleration, but in this case, the acceleration is 0. What we are going to study is the case when the acceleration is not 0, and the case when the acceleration may be positive, may be negative, but the rate of change of the velocity respect to time is constant. It's always change the velocity at a constant rate. It means that if the velocity change in 1 meter per second, it will change in the next second 1 meter per second. It will change in the next second 1 meter per second. So if you start with a case of initial velocity v0, 1 meter per second, after 1 second, your new velocity will be 2 meters per second. After 2 seconds, your new velocity will be 3 meters per second. So the graph will not be this one. Oh, the graph should be a rectilinear line because the slope is constant. So this is what we are going to study. Let's go to study this subject in detail. Imagine that we have an object that his velocity is changing. Imagine that at t equals 0, his velocity is 0. At t equals 1, his velocity is 5 meters per second. T equals 2, his velocity is 2 meters per second. T equals 3, his velocity is 15 meters per second. What is happening here? What is happening here is that the velocity is changing. At what rate is changing the velocity? Well, it's changing 5 meters per second in every second. So the increments delta v is 5 meters per second, and this is happening continuously, constant. 5 meters per second in every second. In every second, from 2 to 3, the change in the velocity is 5 meters per second. So what is the acceleration? The acceleration is a measure of the slope. Is the slope, is the change in velocity, the vertical distance, divided by the change in time, the horizontal distance. In this case, the acceleration is positive meaning that the velocity is increasing all the time. So the change in velocity in this case is 5 meters per second in every second. So the acceleration is 5 meters per second square. What does it mean 5 meters per second square? It means that in every second, the increment of the velocity increase in 5 meters per second. This is what it means 5 meters per second square. And what it means an acceleration of minus 5 meters per second square. It means that in every second, the change in the velocity is negative, is minus 5 meters per second. What it means that? It means that if you start with initial velocity 100 meters per second, after 1 second, your velocity, if you start with 100 meters per second, after 1 second, your velocity, if the acceleration is minus 5 meters per second square, your new velocity after 1 second will be 95. After this following second, you will lose another 5 meters per second, so it will be 90. 3 seconds, it will be 85, etc. And of course, it will arrive at a point when the velocity will be 0. And of course, after it arrives at 0, it will be minus 5, the velocity. V versus t, minus 10, minus 15. And the velocity will decrease and decrease. How it will decrease? In 5 meters per second every second. So the graph of something that is decreasing at a constant rate is, you know what is the graph, is a rectilinear line. Sorry that I didn't go perfectly. So, what we are going to study. So this is the case. V is changing as a constant rate. So the acceleration, A versus t, acceleration versus t, the acceleration is constant and is the change in velocity per unit of time divided by the change in time. And the acceleration in this case is constant, is plus 5 meters per second square. If it is plus 5 meters per second square, if the velocity is changing. Now our question is like this. We know that constant positive acceleration should mean that the slope is not constant, because constant positive acceleration means that the slope in the graph x of t is changing. So, if the graph on x of t, the slope of the graph is constant, the velocity is constant. Now we are studying the case where the velocity is not constant, so the slope must be changing. So you need to have something like this for the x of t. And in this graph x of t, the velocity here, that is the slope, is 0. It almost is not moving, it's not displacement. When the time is passing, there is no displacement. As the at the time run, the slope is bigger and bigger and bigger. So the slope is changing in the graph x of t. What it means that the slope is changing? The slope in the graph x of t is the measure of the velocity. So the velocity here is 0. Maybe the velocity here is 10 meters per second, because the slope is like this. Maybe the velocity is 50 meters per second, because the slope is bigger. Maybe the velocity is 20 meters per second, because the slope is changing. So in this case, we will know that we have a motion with constant acceleration because the slope is changing at a constant rate. So it's logical to expect that in a motion with constant acceleration, or velocity changing at constant rate, the graph of x of t will be like this. Indeed, it will be a parabola. Let's go to see more things. So, when the acceleration is defined like the change in velocity per unit of time, this equation is important. The change in velocity is a by delta t, no doubt. So this is the graph of the velocity, this is the initial velocity, this is the graph of something that is changing the velocity but is changing at a constant rate. Why I know that it's changing at a constant rate? Because it's a rectilinear line, and a rectilinear line doesn't change its slope. Always the slope is constant. So the change in velocity is a by delta t. So the slope in a graph b of t is the acceleration. The change in velocity per unit of time is the acceleration. And this is the equation that we will use. Perfect. So here is the change in velocity. This is this triangle. And here this is the interval elapsed. The time interval elapsed. Delta t. Okay. So the two equations that you are going to use is A equal delta V divided by delta T. Delta V obviously is A multiplied by delta T. And from this equation, I can obtain this equation if T0 is equal 0. Because delta V is V final minus V initial. So delta V equal A by delta T means that V final minus V initial, delta V is A by T final minus T initial. If we write T initial like 0 and T final like T and B final like B, we will obtain V minus V0 equal A by T, or equivalent V equal V0 plus A by multiplied by T. So this is the equation that follow the velocity when there is a constant acceleration. Now the question now, it will be about position. What will be the equation about the position? Before going to this problem, what will be the position that we already smell that the position will be like something curved like in a parabola. Before, let's go to do this problem. This problem say like this. Imagine that you have an object, and the object is accelerating at 5 meters per second in each second. Find the acceleration. Well, if the object is accelerating at a rate of 5 meters per second every second, the acceleration will be, well, is the change in velocity per unit of time. So it's changing 5 meters per second, velocity is changing in every second. So the acceleration must be plus 5 meters per second squared, no doubt. The second question says, if the initial velocity is 3 meters per second, construct the graph of v of t for the case when the acceleration is plus 5 meters per second. And the second question says, find the equation of v of t. This is really a repetition of what we did with constant velocity in the graph x of t. But instead of doing this in the graph x of t, we are going to do it in the graph b of t. So, first question, this is the acceleration. The acceleration is a equal 5 meters per second squared. Second question, if v is equal 3 meters per second, how you will construct the graph? The acceleration says that the change in velocity is 5 meters per second in every second. In every second, the change in velocity is 5 meters per second. So, how I will construct the graph? Well, I will say, I start with this velocity, 3 meters per second. If I change, if I move in 1 second, every second that I move, the change in velocity will be 5. So I am at 8. 5 more. I will move another 1 second, and the change in the velocity that will occur will be 5 meters per second. 8 plus 5, 13. So now I am at the 13. So the velocity is 13 meters per second, which was 8 meters per second. And the graph will be this rectilinear line for the case of A equal 5 meters per second square. So the slope of this graph, delta V divided by delta T, in this case delta V is 5, delta T is 1, the slope will be 5 meters per second square. So the interpretation of the slope of a graph Vt is, the slope is the acceleration. So the second question says, can you define an equation for this situation? And the equation is already written before. The acceleration is the change in velocity per unit of time. So you will write A by delta t equal delta v, and you will say, okay, this is my starting point. So equal v final minus v initial, 3, equal A by delta t, t final minus t initial. What is t initial? 0. So I will not put the 0. T minus 0 is t. So v minus 3 is equal A by t. So this means that v is equal 3 plus A by t, but A is 5, is the acceleration, by t. So the graph of this function, the graph of v of t equal 3 plus 5t, is this equation. This equation, this rectilinear line, where you can see that the slope is what is the factor, is the number that is being multiplied by the term t, by the linear time. So the problem is solved. The two questions are solved. So let's go. In the case that we solved at class was a case that was different. We start with 100 meters per second. The acceleration is minus 5 meters per second squared. We used our equation v of t equal v0 plus aet. We write our equation v of t for this graph. It was v0 100 minus 5t. And we calculate the time t necessarily for obtain v equals 0. When v equals 0, t equals 20. When v equals 0, it means this is 0. 100 minus 5t will be equal 0. 100 minus 5t equals 0. So solving this equation, we will obtain that t is 100 divided by 5, so t equals 20 seconds. So this is what we did in class. So question now. Now question. What is the average velocity in a motion with constant acceleration? What it means, the average velocity? You are moving with velocity v0. You finally will end with velocity v because the velocity is increasing. Between v0 and v, there is any velocity that represents the average? So this is something like asking you, you get a grade of 10, and after in a test you get a grade of 10. Next day you get a grade of 12. Next day you get a grade of 14. Next day you get a grade of 16. Next day you get a grade of 18. So you are doing better in every test. Your grade is increasing 2 points from for the initial 10 points you are going. So maybe you do 10 tests in this interval, 10 days. Okay, in 10 days, you will start with 10, 12, 14, 16, 7, 18, etc. What is your average grade? Well, it's exactly, more or less, is the same question. What is your average velocity between V0 and V? Between V0 and V, your average velocity is V0 plus V divided by 2. We will see this in a different way later on. So this is V0, this is V, and the average velocity is between this height and this height, half of the way. So the average velocity will be like this. This is V average. The average. In the middle between this distance, you divide that by 2, and this is the average velocity. V0 plus V divided by 2. But this is the average velocity between this interval of time, between 0 and t. If you take a big interval of time, it will be another average velocity. So what happens is that in a constant, in a motion with constant acceleration, with constant change in the velocity, this is true. In general, this is not true. But with constant acceleration, this is true. So, the question now is how we can predict the position at a future time. So this was our initial question, and we smell that the position should be like a parabola. So let's go to do it in a mathematical way, using the facts that the V average is V final plus V initial divided by 2. So for one side, we have that the acceleration is constant. The acceleration constant means that the slope is constant here. The change in V is always at the same rate, 2 meters per second in every second, 2 meters per second every second. So the acceleration is like this. So the velocity must be a rectilinear line. So this is the velocity, and this is V average. So the total displacement that he will suffer will be like he's running at a constant velocity. But the velocity, which one will use, V0 or V final? We will use V average, the average velocity, because the average velocity will reproduce exactly the displacement that will occur here. So the total displacement will be V average by time. So we plug in V average, V plus V0 divided by 2 by time. We plug in the value of V final. The value of V final is related with the time elapsed, and with the acceleration, the value of V final is V0 plus A by T plus V0. We work this equation, and we obtain this equation. And this equation is a parabola, so we know x of t. So, the summary, every time that you have a motion with constant acceleration, the acceleration is 5 meters per second, the velocity is the initial velocity plus a by t, and the position is changing with time in this form, x0 plus v0 by t plus at squared divided by 2. And this is what you have done in this explanation, is what you have done in the homework, in the assignments about explain this. So let's go to explain more clearly. X0, you know that it has 3 factors. X0 is the initial position. B0t will be the displacement, as it has never changed the velocity. But because it has changed the velocity, so if it never changed the velocity, the position will be a rectilinear line, a slope constant. But because the velocity is changing, he is performing more displacement than for the case of constant velocity. So this term that is here is the additional term 1/2 AT squared that appear for the facts that the velocity is changing all the time, and it's changing at constant rate. This term is only valid if the acceleration is constant or the velocity is changing at a constant rate. So the other thing that I want you to pay attention to this, because you will solve a lot of problems by using this. I say the area below a graph B of t represents the displacement of the object. So if you have V of t, any situation where the velocity is changing, let's say like this, and you see the area below the curve, the total area, I say that the total area represents the total displacement. So the total displacement between T1 and T2 is equal to the total area below the curve. Whatever you see below the curve is the total area that you see below the curve represents the displacement. So if you see a big area, there is a big displacement. But why is that? Imagine that you move from here to here. Let's go to move this small ddt, this small delta t. Let's go to put it here, delta ti. What is vi, the velocity? At this delta t, there is a velocity. What is vi by delta ti? Oh, vi by delta ti is the area here. But what is the small displacement for this vi, for this velocity at this instant? Oh, is vi, the displacement is v by delta t. So vi by delta t represents the small area, and the small displacement, vi by delta t is the small displacement. So if I sum all the small displacement that happen to be in these rectangles, the curve, below the curve there are many, many rectangles. If I sum the area of all the rectangles, I'm summing the total displacement. So the total displacement delta x will be the sum of all the small displacement that are happening. So the area below the curve will represent the total displacement. If you use this idea to solve problems, you appreciate. So, question 1. In terms of y of x, what is the equation of a parabola? Well, you know, y of x is ax squared plus bx plus c. If the first term disappears, the equation will be a rectilinear line. If the term ax squared disappears and it appears bx plus c, the equation of y of x will be a rectilinear line. But because this term appears, the equation is a parabola. Okay. Question 2. In terms of x and t, what is the equation of a parabola? Well, the answer is, this is t. This is the x. This is the input. Now this is t. This is the input. This is y. This is the output. This is x. This is the output. So everything suggests that if you change in the equation y of x equal ax squared plus bx plus c, you change the y by the x, the x by the t, meaning the output is y. Now
First,
the output
use face recognition to unlock the device.
is x. Sorry. The output is y, now the output is x, so I will write the output. Instead of write the x, I will write the input. The input is x, Now the input is t equal a, the x. The x is the input, so I will write the input, t squared plus v by the x, the input, plus c. So this equation represents a parabola in terms of position and time, no doubt. Okay, so what we have here is a parabola. This equation is a parabola. So the motion with constant acceleration produces a graph in position versus time that is a parabola. So let's go to do one problem. The problem is like this. A car is at 900 meters of a tree. So this is 900 meters. He is initially at x equals 0, and he's moving with 8 meters per second. And he decelerates at a rate of 4 meters per second. So the acceleration is 4 meters per second squared. He's changing his velocity in 4 meters per second every second. So the question is, will he stop before of the distance 900 meters? This is an important question, because if he doesn't stop before the distance 900 meters, he will have a collision with the tree. So we need to calculate perfectly if he will stop or not. So let's go to do the calculation. So how we will do the calculation? We will find the velocity v as a function of time. The velocity starts at 8 meters per second, but because he put the brake and he is decelerate at 4 meters per second square, he will decelerate in 4 meters per second in every second. So in the first second, his new velocity after the first second will be 76 meters per second. And the equation will say everything. So let's go to find the time t when he will be stopped. And we will use this time t to use this equation and to plug in this time t to know what is the distance x when he will stop. So this distance x of this time t, maybe it's 900, maybe it's bigger than 900, maybe it's smaller. Let's go to calculate. So to calculate, the condition is like this. T equals 0, we put initial condition, and x equals 0. The car is at the position x equals 0. His initial velocity is 8 meters per second, and his acceleration is minus 4 meters per second squared. So he's changing his velocity in 4 meters per second every second. So the equation that say this is that Vt is equal v0 plus at, or in other words, v of t is equal v0 is 80 minus acceleration minus 4 by t. So when he stops, the velocity is 0. So we will plug in a 0 here, and we'll see what time t he will stop. And he will stop at the time t equal 20 seconds. Now we will plug in this 20 seconds into our equation for x of t, and we will find what is x when the time t is 20. X of 20 is x0, 0, plus v0, 80 by 20, minus 1/2 a minus 4 t squared. X of 20 is 800 meters, and he's safe, and he didn't have any collision with the tree. So now we are going to talk about free fall. Free fall is what is happening when you launch an object up. Oh, if you launch an object up, it's not falling. This is free fall, when you launch an object up. So what is happening? The Earth is creating a gravitational field that produces that every object that he sees near the surface of the Earth is being pulled into the center of the Earth with an acceleration of 10 meters per second square. every object. Fat people, thin people, big mass. He doesn't care what is the object. He just pull the object with the same acceleration. He doesn't care, the Earth doesn't care if the object is small, it has a shape of whatever, it has a color red. He doesn't mind how is the object. He pull it with the same acceleration, 10 meters per second square, to the center. Now, we are going to simplify because in this acceleration is not constant because the Earth, first of all, the acceleration is going to the center. But the acceleration is changing. When the object is far, the acceleration is smaller. When the object is very far, the acceleration is tiny. So the acceleration is not constant. The other thing that why the acceleration is not constant is that if the object is here, the acceleration is in another direction. So it's not constant because the direction has changed also. So, but we simplify. We have the surface of the Earth, and we imagine the surface of the Earth is a plane. And we imagine that we are very near the surface of the Earth in a way that the acceleration is always 10 meters per second square going down. Now, the problem is like this. The problem is the same problem that we have already studied in the previous example with the car. The problem is, if I have an object and I launch this object with velocity minus 30 meters per second, when it arrives, the acceleration is going downwards. So the object is being accelerated. Even if the acceleration is negative, the object is being accelerated downwards. So the velocity of the object is increasing negative, bigger and bigger and bigger in a negative magnitude. And when he arrives to the floor, he will arrive with a big velocity going downwards. So we use this system of reference. The positive direction is going in this direction, up. The negative direction is going to the floor, negative. So doing this, we can solve the problem. So the problem will be, if the acceleration is minus 10 meters per second square, what will be the velocity of an object if the object is launched at velocity v equal minus 30 meters per second? So we use the same equation, v of t equal v0 plus a of t, e by t, but now the direction is happening in the direction of y. It's not happening in the x direction, it's happening in this direction. And the equation will say that v of t equal v0 minus 30 minus 10 by t. Okay, this is the velocity. Negative velocity means that the object is moving in the negative direction. The positive direction is up. So what is y of t? We will use the same equation. It's t of the x is the y. So y of t will be y0 plus v0t plus 1 half a t squared. So y of t will be y0. So let's say that I launched the object from the head, y0 equal plus 100 meters up in the positive direction, 100, plus v0 minus 30t minus 1 half 10 divided by 2 t squared. And this will be the equation of the motion of this object that is being launched with velocity minus 30 meters per second going. The minus means that it's going to the earth, to the door. So in this equation, from this equation that we have obtained, we can ask when the object will hit the ground. When it will hit, when y is 0. because it was y100 when it was the object at the initial moment. When y0, it will hit. So the question it will be, if y of t is 0, if this y is 0, what time t he will hit the floor, the ground? So you put the equations y equals 0, 100, minus 30t minus 5t squared, and you have this equation. But this equation is how to solve the quadratic equation. So we reorder this equation. We change the sign because 0 and minus 0 is the same. We change the sign to this equation, and it will be 5t squared plus 30t minus 100 equals 0. And we use our quadratic equation that you have to review to find the value of t. The quadratic equation that you have studied is when you have a parabola, ax squared plus bx plus c equals 0, means that the parabola is crossing the axis, the horizontal axis, the x-axis in this case. When he's crossing the x-axis, how you will solve this equation? X equal minus v, this term, plus minus square root v squared minus 4ac, divided by 2a. So I leave you to find at what time he will hit the equation by solving this equation. So good luck. No, not good luck. The summary for constant acceleration. When you have an object that is subject to a constant acceleration, means that the change in velocity is constant in every second. And this means that the velocity change linearly with time. And position change like the square of the time, like t square. And free fall is a particular case of constant acceleration. So don't be confused by free fall. Is not a different thing that motion with constant acceleration. Is exactly the same thing. It is the case when the acceleration is constant and the value of the acceleration is minus 9.8 meters per second square, or approximately minus 10 meters per second square. So finally, the equation for constant acceleration, whatever it happens in the x direction or in the y direction, like a free fall, the equation will be a equal a0, v of t equal v0 plus a by t, and y equal y0 plus v0t plus at squared divided by 2. I hope you can do now problems.